All right. So for today's lessons, we're going to be focusing on square roots, squares, and absolute values. So for learning intention, it states that we're going to be learning to combine properties of equality and equivalent expressions in order to write equivalent equations, inequalities, and formula. And we're still focusing on standard 8EE7. In order to be successful at this, it states, I will be successful when I can solve an equation by using the inverse of squares, square roots, and absolute values. Before we start, I want us to go through just like a recap of the multiplicative and additive inverse first. So I'm going to write a question on here. So let's say the multiplicative inverse. We know when we're doing the multiplicative inverse, say we have 2x is equal to 6. If I'm going to do the multiplicative inverse, since 2 is multiplying x, I have to do the opposite. Okay, so the opposite of multiply would be divide. So I would divide 2, and whatever you do on one side, sure enough, got to do it on the other side. So x is equal to 3. If we have another question like x over 3 is equal to, let's say, 4. If I'm doing the multiplicative inverse, I do the opposite, right? So x over 3, since it's dividing, I have to multiply by 3. And whatever you do on one side, sure enough, got to do it on the other side. So then wait, let me change colors. So then x, those cancel out. We know the multiplicative inverse is always equal to 1. So x is equal to 12. Now let's do one with the additive inverse. If I have x plus 3 is equal to 8. And I'm going to do the additive inverse because I'm trying to find x. Since it's plus 3, I do the opposite, which is minus 3. And whatever you do on one side, sure enough, got to do it on the other side. So then x is equal to 5. Let's do one more question. Let's do y minus 8 is equal to 3. Since it's minus 8, you guessed it, we do the opposite, plus 8. Whatever you do on one side, sure enough, got to do it on the other side. So y is equal to 3 plus 8, which is 11. With these 4 questions we did just now, we focused on doing the inverse, which is the opposite of the operation. So if it's minus, we do add. If it's plus, we do subtraction. If it's multiply, we do divide. If it's divide, we do multiply. Resume. So the first thing we're going to look at is solving equations with squares. When I talk about squares, I'm talking about, say we have the variable x squared. We've been dealing with polynomials. So now we're going to be looking at how do we solve some of those when we put them in an equation format. So x squared, y squared, z squared, all of those. So if I give an example here and I say x squared is equal to 4. And the question is, what is x? Similar to how we were solving those multiplicative inverse and additive inverse questions, I need to find what x is. I need to find x. I need x to be by itself. As of now, it's x squared. And we know x squared means x times x, right? So in order to get rid of squares, I'm going to do the inverse. And the inverse of squares is the square root. And whatever you do on one side, sure enough, you got to do it on the other side. So with squares, in order to get rid of squares, we use the square root sign. We could look at our calculator and it's going to be in the top 3 rows. The square root sign is there. So whenever we're finding square root, we put our square root sign in, then we put the number, and then our answer will pop up. With this case, since square root is the opposite of squares, then this right here becomes x is equal to, and then the square root of 4 is 2. If you don't believe me, go check it on the calculator. So square root of 4 is 2. So x is equal to 2. Before I had x squared and they asked me for x. They didn't ask me for x squared, so I have to get x. So I do the square root on both sides to find what x is. Let's give another example. Say y is equal to, y squared is equal to 16. In order for me to find what y is, find y, I need to use the square root. All right, whatever I do on one side, I got to do it on the other side. The square root of y squared is y. The square root cancels it out, just like how plus 3 cancels out minus 3. The square root cancels out the square. So y is equal to square root of 16 is 4. Okay, another part that I'm going to do, let's use x squared again, is equal to 25. And they're like, Mr. McKnight, how do I find x? Well, first, I got to use the square root sign because I got a square right there. I got to get that out. And whatever you do on one side, sure enough, got to do it on the other side. So I'm going to say x is equal to, I'm going to add something into this. X squared means that x has two values. The number at the top means that x has two values. If this was x cubed, it's telling me that x has 3 values. So x squared in this case has 2 values. The questions I was working before only had 1. And that's because I didn't introduce it. I'm doing it now. So x, it would be equal to a positive 5 and a negative 5. Because the square root of 25 is 5, right? But now I have to separate it into 2 values, which is a positive 5 and a negative 5. Let's do one more example. If I say y squared is equal to 100. You said it. Well, you didn't because I can't hear you. But the square root of y squared is y. And I have to do the same thing on the other side. So y is equal to positive 10 and negative 10. The square root of 100 is 10. But then it has to have 2 values because my y is squared, which is telling me that y has 2 values. So it has to be the plus and the minus of whatever the square root is of that number. All right, so let's now look at some questions starting with the square root. So we're just doing the opposite of what we just did. We're going to reverse it. So before I gave you x squared is equal to 16, now I'm going to give you, let's do square root of x is equal to 2. And the question is find x. As of right now, I have square root x. That is not just x. I need x to be by itself. In order to get rid of a square root, I square it. And whatever you do on one side, you do it on the next side. So my square cancels out my square root. All right, and since my square cancels out my square root, I'm left with x. And then I do 2 squared. 2 squared means 2 times 2. And 2 times 2 is 4. So x is equal to 4. Let's do one more example. If I have x plus 3 is equal to 8. And I need to find x. I have to get rid of that square root sign by squaring it. Whatever you do on one side, sure enough, got to do it on the other side. So then my square cancels out my square root. So I'm left with x plus 3, and 8 squared is 8 times 8, right? Which is 64. Now I go to my additive inverse. So I do minus 3 on both sides. And so x is equal to 61. So just to recap a little bit, if we have an equation underneath a square root sign, in order to get rid of it, we square it. All right, whatever you do on one side, you got to do it on the other side. All right, the last one we're going to look at is solving equations with absolute values. All right, I remember we did something like just briefly a couple weeks ago. If we have the absolute value of -8, we know that it makes it positive. All right, so then that answer becomes 8. Now, what we're going to do, we're going to try and solve some equations with it. So for example, if I give the absolute value of -2x, let's make it interesting. Absolute value of -2x is equal to 8. In order for me to solve this question, I need to put -2x is equal to 8. There are going to be two values for x. -2x is equal to 8, and -2x is equal to -8. When I write it out like that, it immediately gets rid of the absolute value sign, because the absolute value is telling me that there's a positive value and a negative value. So I write up my equation using a positive value and a negative value. And then from here, I do the multiplicative inverse. So I divide both sides by -2 for both my equations. So x is equal to -4 and x is equal to 4. Two values. Let's do one more example. If I have the absolute value of 2x plus 3 is equal to 16. Okay. In order for me to solve this, I need to separate the equation in two ways. First way is 2x plus 3 is equal to 16, and 2x plus 3 is equal to -16. All I did was just separate the value into two parts, a positive value and a negative value. Now I solve like I normally solve equations. I do the additive inverse first, and then I do the multiplicative inverse. So I'm -3 on both sides for both equations. So 2x is equal to 13 on that side, and then on this side, 2x is equal to -19. I do the multiplicative inverse now, so x is equal to 13 divided by 2. And then on this side, x is equal to -19 over 2. All right, so that's kind of just a brief introduction to solving equations with squares, square roots, and absolute value. Just always remember, we're trying to get x by itself. So if there's a square root there, we need to get rid of it. If there's a square there, we need to get rid of it. If there's an absolute value sign, we need to get rid of it. Similarly to how if there's a number blocking the variable, we need to get rid of it. Okay. If you have any questions, you could reach out to me. Just let me know. Just to go over the success criteria again, it shows that we'll be able to solve equations using the inverse of squares, square roots, and absolute value.